Hey everybody, this is Larry. This is day, how do I not know the day? Day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. This is a hard problem. So, yeah, let me know what you think about today's problem. But before that, as you know, I usually, not usually, but when I have something to celebrate, I will try to, just bring the positive vibes a little bit. And earlier, I don't know if that went up or down, but yeah, I finished in the top 50 second, top 52. So yeah, that's something to celebrate, I guess, a little bit. So it always feels nice to, yeah, not to, brag or anything, because I've been able to do better. I'm trying to be, I've been able to do better, but still little victories, still celebrate them. That's what I'm trying to bring. Okay. So yeah, hope you did okay if you did that contest. If not, what I always think about it is that these are learning experiences. If you didn't do so well, then try to figure out what are the learning lessons, right? And even sometimes when you are doing well, what are the learning lessons, right? Meaning maybe I could look at other people's solutions and see how they did better. And I kind of there are a couple of things where well, maybe not this one per se, but there are a couple of things where I was like, oh, you can do something like this. To be slightly cleaner and then faster, and versus I always spent a lot of time debugging. But yeah, anyway, so my point there is just there are a lot of opportunities. There are a lot of opportunities to learn in these contests, in these problems, in life, in everything, both in failures and successes. So yeah, hope you kind of take the opportunity to kind of slow things down, breathe in, breathe out, and see if you can figure out like don't beat yourself up or congratulate yourself too much, but try to figure out how if you want, if the timing is right for it, to be slightly better, right? Or just learn, right? Like you don't have to be better for anything or anyone, but just if you want to improve, then figuring out where the improvement's going to come, right? Be deliberate about it. Don't just be like, oh, if I solve 100 problems, I'll be better. If I solve 200 problems, I'll be better, right? I mean, yes, but if you're more deliberate about it, if you made the deliberate the connections in your mind about all these problems, then it'll probably be a little bit better. The only other thing, I guess I've been kind of rambling on a little bit, so I might as well say that one more thing that I always say, but I think people don't always understand or don't. People just really brush me off. Maybe I'm just like that old guy screaming at the clouds, being like, "Hey, listen, kids, do this." But the other thing is just that I think the trap that a lot of people fall into a bit, and I don't know if that's quite the right word, but a lot of people try to do, and that's it's a noble goal, and as someone who probably is also was doing the same thing, a lot of engineers are into optimizing and optimizers, and being optimal in a lot of things, but learning is not. Life is really long. Also, it is very short, but what I mean is that like being efficient doesn't matter as much as being consistent, because when you're consistent, it doesn't matter how well. I mean, okay, within reason. If you're consistent and you're deliberate, meaning that you're working toward your goal and not necessarily just doing things mindlessly, you're going to learn, right? It's fine. You'll be better. You'll get yeah. So I think as long as you're kind of putting in the work and in a consistent way, you'll get better. It may not be the most efficient way, but I mean, unless you start too late and you didn't pace yourself and you didn't give yourself time to kind of get good, like you'll get there eventually, right? Like if I set a goal to, I don't know, go to the gym and like, I don't know, like do bench press on a really heavy weight or something, right? Then it doesn't really, like it that's not really achievable if I haven't been consistent. But if I just say like, okay, I eventually want to do this, and every session I'm deliberately trying to look for how to be slightly better, then you'll get there eventually within reasons. There's also physical limits and stuff like this, but you get the idea. Anyway, all right, sorry friends, it's been 5 minutes and I still haven't started the problem. Hopefully, and it's too late for me to say this, but hopefully if you weren't interested in all that, you'll fast forward, or maybe you already left the video. If you're still watching here, give yourself some props, and also let me know So I am looking for some movies to watch. So let me know what your favorite movies are for this year in the comments below. Give you props for that. Okay. So today's problem is 446 arithmetic slices 2 subsequence. So given an integer array nums, return the number of or arithmetic subsequence of nums. Okay. I don't know what that means, but let's see. N is 1,000, so that's usually a little bit of a tell that n squared is okay. In Leetcode and in Python, it's a little bit sketch, but conceptually, that's what they want you to believe. So that's the first thing to see. But what does it actually mean? So three elements, and the difference. Okay, so yeah, arithmetic subsequence. Okay. So it doesn't seem like it's so bad. Do we have to do? Oh, okay. I was gonna say, is there some modding thing because it was likely to go over the 32-bit limit, I guess. Because if you just have even just like all ones, if you have like 40 ones or 32 ones, it'll already be over the limit, and therefore you need to mod, which is why I was like, let me look for it, just in case, right? Okay, but the short story here is going to be, how do you say it? I mean, I don't, I feel like I just call everything dynamic programming, and maybe it is, but it's more like a lookup, I suppose. And the thing is that because n squared is fast enough, but we still have to be a little bit deliberate, right? Yeah, n squared is fast enough, so then we can, as long as we have all one lookups, that should be good enough. So okay, so I think the idea then should be okay. So I'm gonna write out a skeleton, and then we'll write out what it means to kind of move on from that skeleton and kind of do more stuff, right? So for example, let's just say n is equal to length of nums. So for I in range of n, for j in range of I plus 1 j n, maybe we like to go the other way around. Okay, let's go the other way, actually. Doesn't really matter, I think, but from 0 to I, and then now, what does that mean, right? So we have some delta is equal to num sub I minus num sub j. In this case, remember that I is the number after j, right? So yeah, so this is going to be the delta going forward, and then the question is so how do I say it? How or what is the longest subsequence, or how is it how many? That is very awkward, right? Is it? I don't know. Let me think. Is it the longest or how many? Because the idea here is subsequence, right? Yeah. The idea. So the thing that I'm trying to figure out a little bit is, for example, we have, say, same as the first input, but just 2, 2, 4, 6. Let's say we do 4 and 6. We go, okay, the delta is 2, so then we look up the 2, right? Okay, no, I mean, I think the number is good. I think because then now you're saying, let me add, no. Let me think. This one may be a little bit tricky too. So I'm just thinking through all the edge cases here, right? So there are two possible ways you can, or there are probably more, but this is what I'm thinking about. So what I'm thinking now is that, okay, so the idea behind, if there's a count, right? Then then here at the, let's just say delta's, let's just say 4, -2 or something like this, right? Because we're going delta backwards. Maybe not. Maybe that's a little bit confusing. But the idea here is that, okay, then it looks up there's 2 2s, right? Which then allows you to kind of, just be, the idea here with the dynamic programming mindset is that, okay, we're adding a 6 to all those sequences, right? And there's some stuff about keeping it at least 3, but that's, that's fine. Like we can work around on those constraints. It's not that bad, at least in my head. Maybe I haven't talked about it yet. But then the idea here is also like, let's say there's a 0 in front, right? I mean, I don't, yeah, 0 is an input. Then here, yeah, there's still 2 possible cases, but what I also want is now, so here the cases, you know, the 2, 4, 6, and then there's a second 2, 4, 6, or, you know, you could say that there are two 2, 4s, you know, one, and then you add 6 to each of these, right? And then the second thing, of course, is just 2, 2, 0, 2, 4, 0, 2, 4, right? But then now, once we kind of get over the relimit thing, we want to add a 6, right? But then now, instead of just getting count, we also want to, instead of just getting a count, we also want the length, right? Because the length means that, okay, we have one of length 3 and one of length 4. And of course, if we have to do any sort of iteration more than whatever, then it's going to be n cubed, and we want to avoid that. That's what, sorry, I'm like trying to think through it in my head. Okay, but still, I think this, so still this is basically the idea. And then here, let's see. So then maybe we want some lookup of num sub j being the earlier number minus delta, right? And so that's the last number. And then we also keep track of delta in some way, right? So this is like the lookup thing. But then what is the lookup? Is it, did I miss something? I feel like today I'm just a little bit off on this one. Okay, well, let me think about this. Because we have to look. Is that parsed in? No. If the length is whatever, and we also need to. Maybe I'm doing it in the wrong direction. Let's see. Let me see if I can try to reset. I think this is still the right idea, but I'm doing something. I'm missing like one observation today. I think I see. I think instead of, I think what I was trying to do is being too clever. Because I think I'm doing too, or like I think I see, okay. I think what I was trying to do in a way was making an optimization without realizing it, because what I was trying to do is dedupe things unnecessarily, right? And this is maybe, you know, one of those things where if you solve enough problems, you do some you know, you do some tricks in your head without realizing, right? And what I mean by that is that you know, with DP, it's maybe it was, you know, like given this input, I was able to, you know, like if you look at the states that I was trying to represent, you can see that here I'm putting in the number. In this case, it would be the 2 and then the -2 or 2, I don't know, whatever, right? Where maybe I don't need to be that complicated. What I could do is what I could do is simpler, right? What I could do is just that we don't need to dedupe it. Would I keep it duplicate and then just keep the lookup by index, because then now we can be more strict about what we want, which is what is the length of the longest subsequence. And the reason why we want the length of the longest subsequence in this case, as I said, is that let's say we have 1, 3, 5, 7, 9 or whatever, and then now let's say we add a 11, right? Well, if this thing is 6, then you can just do the math on, you know, there's 1 on 3, 1 on 4, 1 on 5, 1 on 6, right? So then you could kind of do the math that way and then just put it in I or whatever. Okay, I think now we're in a good place. Yeah. Okay. So let's just say lookup is equal to this, and then every time we we append I don't know, just default date maybe. Int. Yeah, because this is the count, so I guess technically counter, fine. Right? Yeah, and then the delta is this, and then we just basically want lookup of j. And yeah, maybe I could have also just used a thing, but maybe this is slightly better. So yeah, is if delta in lookup of j, then what happens, right? Then we get the count. So count is equal to this, and then now, oh, this is the length, right? Not the count. I confused myself again. Sorry. Okay, fine. Good, because I changed this to counter. The reason I don't want to use it as count is because it is supposed to be a length, so that's why this is kind of confusing. Okay. Yeah, okay. Is this right? Am I confusing myself? Hmm. Hmm. Am I confusing myself? Do I want to do I want the length? How do I do it this way? Okay, let me. I think I'm just very wrong actually. Sorry, people messaging me. So let's see. Okay. So I of delta we added to count. So that's not really. It doesn't really make sense for it to be the longest. It does it in this case, because here it's saying that that's how many counts there are. Now I'm just confused. Oh, I see. Okay, I think there's another way of representing it that I kind of messed up. Okay, so if, for example, let's go back to I think this is the one that we had, and then let's say we're adding an 8, right? I think here, if we have 0, well, let's just say that we have n at 6, right? So then there's 2, 4, 6, 2, 4, 6, maybe 4, 6, depending on how we put it, and then 0, 2, 4, 6, and then twice, right? So then let's just say we're trying to add 8 to all of these. So we have the count, we have add 8. Yeah. I guess that's it. Maybe I just confused myself. Because if we already have the total count, I think I'm overthinking this a little bit one of these days. Because if we add 8 of all these, then we have all the lengths needed except for the 2, maybe, and we have to play around with that a little bit. But I think that's okay. Okay. So yeah, so this is equal to this. I'm trying to think about the off by 1 case. Like, how do we construct new ones, right? Because otherwise everything is going to be 0. So, okay. So let's just say that ij, and then this looks up. I guess we can just do this 1 case. Okay, I think this is fine. But then, as long as this is not the final answer, so we have to do the final answer is equal to, I don't know, whatever answer, maybe. And I don't know that there's any more code really, but let me just run it real quick. Okay. Well, this is because this never kicks. Because then we want else lookup of I delta is equal to 1, maybe. Okay. I think I was just. I think the key thing, the key takeaway about word 2. Let me make sure it's correct first. Maybe that's the key takeaway. Okay. Wow. Am I sloppy, or is it a real fake answer or a real wrong answer? I didn't actually expect that, to be honest. I was pretty confident about it. Oh, because well, let's see. Maybe this one thing is wrong because, oh, I see, because if this is 0, oh no, this is +1, whoops, because I confused I and the J here. Okay, silly typo. Oh, not typo, just me not really thinking it through because I got confused about it. Okay, so that actually worked out okay. What did I do the last time? Was I much smarter? I guess much smarter. Actually, is it? I don't know. All right, well, so I think that the thing that I want to emphasize here is that even though I had all the kind of ideas with respect to just having experience about this, I still struggle with this one, as you kind of saw. I think the thing that I would notice, or that I noticed if I was about to talk about, or like if I'm doing a retrospective of, hey Larry, what happened, you know? I think the key thing is visualization. I think I had 2 kind of tricks, if you want to call it that, or 2 tools in my tool set, and I kind of mixed them up and confused them. So that's one. So some people might have a clear, and with more practice, oops, sorry, hit the mic. So with more practice and stuff like this, you would gravitate toward an answer more clearly, just like with practice. The second thing though is that I think honestly, I was just a little bit stubborn, right? And if you kind of watch the entire video, or at least the last portion of it, you'll see me like draw out all the subsequence, right? And I think what happened was that there was a disconnect about, when you see me like deep in thought, it's me trying to visualize it in my head. And not gonna lie, sometimes, maybe I could say that I was arrogant, right? In that I thought I could visualize it correctly in my head when I clearly could not, because I visualized the wrong thing in my head, and that's really all there is. And I was still thinking about the other trick, if you will, of the longer subsequence stuff, and then counting it that way, instead of just doing the count, and then also what the count means, right? And there is a risk and a bit of an error that I did, was that I took a very small example and I extrapolate, and maybe for me, like, most of the time even it's probably correct, at least when I got to that far, but this time I was wrong. Like, what worked for n is equal to 3 wasn't working for n is equal to 4 in my head, because I was just and for this particular one is important because you're trying to figure out like the longest subsequence and stuff, and how they all fit together. And I was thinking more, I wasn't thinking about the totality of the subsequence and how the dynamic program interacts. I was more thinking about what was I thinking about? I mean, I was thinking about it incorrectly with respect to just trying to dedupe the numbers in a weird way, right? Like I wasn't trying to think about it holistically and kind of put everything together. I was just be like, okay, the dupes. How do I resolve this dupe? How do I like? Does is there something that handles the dupes automatically? Stuff like that, right? And I kind of messed up there, and I generalized it incorrectly. And I kind of got confused with my bag of tools. So that's basically what happened. I think the thing, as I was saying, in these cases, the recommendation that I would have for myself if I was looking at my own video and be like, hey, you have to improve on this, is kind of just go back to fundamentals, go back to the basics. And what I mean by that is not necessarily like, read up on whatever, but just, Larry, you're getting old, and you don't practice that much, to be frank. So just draw it out, Like if I had drew it out earlier, I would have saved like 10 minutes and, it would be less confusion. Just draw it out, play with small examples. Yeah, that's basically all I would say about this one with respect to Larry improvement. But I haven't talked about the analysis yet. But like I said, this is going to be n squared just because everything else is O of 1, right? I mean, given two lookup tables or one lookup table in 2 dimensions, everything is O of 1, as you can kind of see. And if it fits in 32-bit int, then it's still, we don't have to worry about, word size and all this stuff or whatever, the integer size. And of course you can see that this is n squared. So yeah. That's pretty much all I have for this one. That's all I have for today. The contest is coming up later. I'm gonna try to get some food and hopefully it doesn't mess up my contest too much. But that's all I have. So yeah, good luck on your contest tomorrow. Either tomorrow or later today. I don't know. Whenever you're watching it, or previously if you already done it, because I don't know when people are watching this. But yeah, and also wish me good luck because always can use a little bit of luck. Yep, that's all I have. So let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.